Okay, so in this video, we are going to look at arrays. It's a very important data structure that we use in Julia. One-dimensional, again, arrays could be of one dimension, two dimension, and so on. So a one-dimension array is typically called as a vector, and a two-dimensional array is typically called a matrix. And we'll see separately matrices in another video. So today we're going to focus exclusively on vectors, which are basically a one-dimensional array. So we're going to look at different ways to create a vector and access elements of the vector and see what can be stored in the vector, what combination of data types could be stored in the vector, and so on. So it's a very important video, so please pay close attention to it. Okay, so one way to create a vector is to specify the range of the values of the elements that you're going to have and just create the array or vector in the, so I could be interchangeably using the terms array and vector. So create them in that order. So let's say I want to store an array of elements whose values are from 1 to 20, and I want every integer in that range. So it could be like 1, 2, 3, 4 up to 20. So I could just then specify the range 1:20, and it's implicitly understood that I want to create an array of integers from 1 to 20 in increments of 1, 1, 2, 3 up to 20. So the increment 1 is kind of by default if you don't specify it. Okay. Now you could specify an incrementer also. So I want to start from 1 and I want to increment by a value of 2 and I want to go up to a maximum of 20. So in this case, it will be like 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. It won't include 20 because in that increment of 2, and 20 doesn't come into picture. So, and it cannot go beyond 20. So 19 would be the last value created in this second array. So I'm using this function called collect. So this collect is a function to which you can pass that range as the argument, and that's going to return an array. So let's run this code and see what's going on. All right, so the first array, which I called as A1, is going to be from 1, 2, 3, 4 up to 20. And the increment 1 is by default, so we don't need to specify the increment if it is going to increment by 1. The second array A2 is, as I just said, 1, 3, 5, 7, 9 up to 19. It won't go to include 20 and it won't go beyond 20 as well. So 19 will be the last element. Now the third array is going to be again created using this collect method. So again, it's from 20 to 30 in this case. Now I specify increment just to show that it could be specified if you want to. You don't need to specify it unless you don't want to, like it could happen like what we had before. It could be the same thing. Now, what I do here is, so this alone, the collect of 20 to 30 alone would create an array like 20, 21, 22 up to 30. Now, I want to reverse those elements. So there's a reverse function to which you could pass that array that you're creating here as the argument. So collect is going to create an array, okay, comprising of elements or values specified in that range. So this array will be from 20, 21 up to 30, and you're passing that array as argument to the reverse function. So the reverse function is going to be like 30, 29 up to 20. So that's what you're going to see here. A3 is going to be, let me pull it up here. So A3 is 30, 29 up to 20. You have reversed that array. So that's the content. These are the contents of it. Because you see here, you're passing that reverse. So reverse function also returns an array and that's stored in A3. So A3 would be the reversed array from 30 to 20. All right. That's one way to create an array using the collect function and passing the range of values that you want to store in it. Now, the second way to create an array is using this format of what's called comprehensions. And again, these are like the comments, multi-line comment statement, as I have mentioned earlier. And this is the format that you can have in general. So some function f to which you could pass arguments or parameters x, y, and so on. And for it's like a loop. And we see loops separate in a new video, coming video probably next week, today, tomorrow, or sometime very soon this week. But so it's like a loop for range of each parameter x, y, and so on. All right, let's say an example. So this is the array named A4. I want to create the exponents of 2 in this array. So exponents of 2 starting from exponent 1 to 20. So I can do it like this, 2 raised to I that's the function. Okay, f of this is a function of just I in this case. And what is the value for range of I for I equals? So x equals like Rx means like range of x. So in this case, I is the x, the variable, and its range is from 1 to 20. Now, if you want, you could play with it. You could specify something like this for I equals 1, 2 up to 20. Then, so that's again an incrementing variable that's allowed when you specify the loop. So in this case, I will be like 1, 3, 5, 7, and up to 19. Let's check it out. Yes. So A4 in this case would be like 2 to the power 1 because I equals 1, which is 2. Then it's not 2 anymore because it's incremented by 2 now. So the next I would be 3. So that will be 2 to the power 3, which is 8. The next I will be 5, which is 2 to the power 5, that's 32. The next I will be 7, 2 to the power 7 is 128. Then the next I will be 9, 2 to the power 9 is 512, and so on. So the last value in this array will be 2 to the power 19, which is this 524,288. Okay. All right. Now, so that's the second way of creating an array using this comprehension format. So again, make sure you specify the square brackets and include that comprehension function within it. Okay. So that's very important to do. So you cannot just A4 say A4 equals 2 to the power I for I equals 1 to 20. You have to include the square bracket. Okay. So these are the two primary ways. We'll see some more ways later down, but let's start looking at some functions we can use on an array. And then we look at a few more ways to create and fill arrays or vectors. Okay. So now that we have seen at least a couple of methods to create an array, let's see how to, now you may think that like once you create an array of some elements, you cannot add anything more. No, it's not, it's possible to add. So in that sense, we treat it as a vector, as a dynamic array, basically. So adding an element to the end of the array. So we already created this array, A4, to comprise of these elements, right? So this is our current A4. So what you want to now do to that A4 is you want to add one more element to the array. Now, where can you add? So we'll see the different ways you can add elements or different places to which you can add elements. Now, one function that we'll commonly use later is like the push function, where the idea is to just add to the end of the vector. So let's start using vector from now. So you can push because we're making a dynamic array. So let's start using it as calling it as vector. So you want to push an element to the end of the vector. Okay, so I call it as array here, but let's call it as vector. It doesn't matter because, as I said, a one-dimensional array is a vector. All right. So the push function will add this 1000 to the end of this array. Okay, so it's going to be like this 1000. Okay, that's where it gets inserted. Okay, at the end of this array. All right. So after the push, the first push, this A4 looks like this. So now you can pop the vector also. So the pop again removes an element from the end of the vector. So you push to the end of the vector as well as pop from the end of the vector. So the push and pop operates at the same region. Okay. So when you call this pop, again, if you look at the syntax of this push, I have this exclamatory mark here. That's kind of like an operator that goes to this push function. That's kind of a syntax in Julia. So if you do it without the exclamation mark, it will generate an error. So let's try it out. You see, so the push function needs to be accompanied, or the call to the push function needs to be accompanied by this exclamation mark. Now, later we'll see that kind of this is like a force operation. The sense that this, including this exclamation mark, say later and look at data frames and all the things, will force that data frame itself to get changed due to that operation being done. So in this case, when you include that exclamation, that means you're forcing that array A4 to get changed. So, and you want it to be changed in the sense that you want that 1000, the value 1000 to be inserted to the end of that vector. So you want that A4 to be indeed changed. So you're kind of forcing it. So this exclamation mark in Julia is basically considered as kind of forcing the what do you call the data structure, whatever at that instant, in this case is a vector, to get changed due to the operation you're calling along with that exclamation mark, which is in this case a push operation. So you want to add an element to the end of the vector. So you kind of force that vector to get changed and include that 1000. Similarly, when you call this pop operation, you want that vector to be changed in the sense that you want the last element of the vector to be removed from the vector. So you want to enforce that change. So you do that by specifying pop exclamation A4. Now, the pop function can also one sec. Yeah. So the pop function can also return a value that's being popped out. So later in another code here, I'm showing that the pop function is returning a value, and you could, because you're popping out that last element in the vector, so that value could be captured in a variable, and you could access that variable and use it for whatever purpose. So even in this case, I could add a pop val, something like that, and store that return that pop value, which is 1000 in this case, and use it for some purpose. So you could print that pop value if you want. So the reason why I avoided using that here is I wanted to show that two ways or not ways, but two different ways you can at least write the pop function. They both basically do the same thing. They pop the last element in the vector. So this statement, I am showing that you don't need to explicitly capture the return value. Okay, so if you want to just pop it out, fine, that's fine. That's you could do that, and by calling pop exclamation A4, and after the pop, it's going to be like, okay, let me run it again. So after the pop, it's going to be like this 1000 is gone, and that's the array. Okay, so it's doing the purpose what you meant it to do. So you don't need to explicitly capture the pop value. If you want, like I show here later, you could capture the pop value. So that's why I didn't do it there, and I'm doing it here. Pop A7, some other array, but I'm capturing the pop value explicitly in a variable. So it's up to you whether you want to capture it or not. All right, so that's about push and pop. So again, push and pop operate at the end of the array. You push to the end of the array and pop from the end of the array. All right, so let's see whether can insert something somewhere within the array, in the middle of the array, or at any specific index. The answer is yes. So there's an insert function. Again, you can see accompanied by an exclamation mark because you are going to enforce the change to reflect on this array A4. So this is the array we have right now. as we created originally, because we pushed 1000 and popped it as well. So to this array, let me use this. So to this array here, I want to insert at index 5 this 1000. So you can call it like this, the array name and the index where you want to insert and the value you want to insert. So that's the syntax. So after you insert, you can print the contents of the array A4 and it looks like this. So this is A4 before the insertion. And index 5 is going to be like 1, 2, 3, 4, 5, where currently you have 512. So you want to insert that 1000 at this index where you have 512, and that got inserted here. So 128 is at index 4. At index 5, we have 1000 now, and then the 512 is just getting pushed to the next index, which is index 6. So insertion is not replacing that value. It's just going to create one more space and just insert whatever value you want to insert at that specific index. So insert is not like replacing. Okay. So that's this is what the array is right now, the A4 array. Now, to replace, what you could do is you could specify a range of elements that you want to replace and pass that range as an argument to this splice function. So a splice function, again, you could enforce it, you will need to enforce it using this exclamation mark A4. And then you could pass a range. Like in this case, I want to replace the element at index 5 and index 6 with these values, -1 and -1000. So you could pass those values as an array. And you could then call the splice function and then print the A4. So this is what happens now. So index 1, 2, 3, 4, we have up to 128. Then index 5 and 6, which you have 1512, those two values are going to be replaced now by -1 and -1000. So I'm using negative numbers to explicitly be able to see that these values did replace some positive values we had earlier. And then so the 1000 and 512 are lost from index 5 and 6 because they're just being replaced by -1 and -1000. So after the -1000, you now have this 2048. Okay, so that's how you could replace a range of values. So you may be now curious to know, can we just try it on a single value? Let's try it and see. I've not tried it, but let's try it out and see whether can we do that. So let's say we want to just change at index 5 and we want it to be some -500. Okay, so I think this will work. Let's print it out and see. Yes. All right. So after the first splice, this is what we had, -1 and -1000. So -1 at index 5, -1000 at index 6. So now what I want to do is just replace the value at index 5. So specifying a range here. So, but you just want to replace that particular index. So you just say 5:5. And within that array, just pass one value, which is -500. And you could just, now this -1 is replaced by -500 and the -1000, everything just stays there. Okay, so this is how you can push, pop, insert, and splice an array. Okay, or a vector. All right. Now, the next set of arrays here we are going to play with strings now. So this is an array of strings. So you could create an array of strings. So A5 is, say, S1 is one string, S2 is another string, S3 is another string. So if again the indexing starts from 1, so if you say A5 of 1, that is basically S1, that's a string on its own. A5 of 2 is a string, S2 is a string of its own, and then A5 of 3 is S3, a string of its own. So if you print A5, it's going to print all those three strings together because that's the entire A5. But as I said, each element is a string of its own. So if you remember in the string module, string video, we saw that the contents of the string could be just what you call increased or expanded by this exclamation mark. Or if you have not seen it, this is the time. I'm not sure. Let me check. I think I used their this star operator. Yeah, the star operator could be used to concatenate. Yes, but not to expand in the sense that or exponential expansion. Okay, so this is like how you say 2 raised to 3, which is 2 times 2 times 2. So when you say a5 of 2, so whatever the string s2 is going to be like expanded by raised to 3. So that's going to be like s2, s2, s2. That's how it's going to be expanded. So a5 of, sorry, a5 of 2 is s2 in the original array a5. So that a5 of 2, which is s2, I'm going to increase it by 3 strings. This not 3, yeah, 3 strings. So raised to 3 means I'm going to make it s2, s2, s2. And you see here, I'm kind of copying the value or assigning the value back to a5 of 2. That's very important. Okay. So if we just say a5 of 2 raised to 3, it's not going to update a5 of 2. We have to assign it back to a5 of 2. So that way, the second index of a5 is no longer just s2. It is s2, s2, s2. So if you want to make it like 4 s2s, so you could make it 4, and let's see, it will get now 4 s2s there. Okay, so there are 4 s2s here. So that's how you could increase that S2. Okay. Now, if you want to trim it, we have seen the functions to trim in the string class or in the string video. So you can use that to trim this back to whatever you want it to. Okay, so that's about string arrays. All right. The next thing I want to show is back to initializing vectors in different ways. Let's say I want to create a null vector or an empty vector with just zeros or with any initial value. Okay, so with any initial default value, then I can call this fill method. Okay, so this fill method is going to insert a default, whatever the value you pass as the initial value to all the elements of the array. Now, you could specify the length you want as a numerical value, say 10 or whatever the length of the array you want to create. So here I just use the size of a5. So again, the length function, which if I have not mentioned earlier, so length function called on an array is going to return the number of the value for the number of elements in the array. So length of a5 is basically 3. So as you can see, a5 has, even though it is s2, 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 it's still one string. And s1 is the other string and s2 is the other string. So a5 is still an array of 3 strings. Okay, so the length of a5 is going to be 3. That's something important to know. So a5 by itself is an array of 3 strings. So the length of a5 is 3. Now, if you are curious to know about the length of this element, the second index, the way you could do that is, let me show that here. And then we could go to this filling thing. So print ln, let's see, length of a5 is going to be length of a5. You can pass it like that, and that's going to print 3. And if you want the length of the string at the second index, length of a5 of 2. Again, this is just a text. We want to use it for our reference. So the way you have to do that is a5 of 2. So that's a string. So you can access that using the index where it is. So that's going to print whatever the length of this is, which is going to be 8 characters, right? So that's going to print 8. Let's check it out. All right, so that's what I was telling. So length of A5 itself is just 3 because it's an array of 3 strings. S1, then there's S2, 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 and S3. So length of A5 is 3. But length of A5 of 2, just this, is 8. So you have to be careful what this 3 and 8 indicates. This 3 indicates 3 strings, which are S1, and this S2, 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 and S3. 3 strings, that's length of A5. This 8 is 8 characters. So A5 of 2 has 8 characters. Okay, so let me make that clear here. So that's going to be 3 strings, and the length of A5 of 2 is going to be 8 characters. All right, so that's important to know. All right, let's now get back to A6. So I want to create now A6 to be an array of 3. And let's say it's a zeros, let's call it as an array of 3 integers. And if you want to, once you start adding a float, it becomes an array of float. Uh, Now, so length of A5 is 3. So it's going to be initially an array of, let's say, just 3 elements. Okay. And because I want to also show that even though it's not typically used, Julia doesn't require an array to be comprising of elements of the same data type. You could have an array where each element could be of different data type. Okay. So let's not call an array as an integer array or a float array right away. Later, when we program it for a specific application, we will do it on those lines, and we can call it as an integer array. But I want you to now remember that Julia does allow an array to have elements of mixed type. Okay, so you could have an array like we see later in this code where one element could be an integer, another element could be a float, another element could be a string, and another element could be a boolean. So it could have a mixed type, data type. Okay, so let's call elements for now. All right, so this is a 3-element array with each element being initialized to 0. That's what it is as of now. So if you print A6, it's going to print all these 3 zeros. So now I want to start applying my push operation to this. So if I say push the exclamation A6 comma 1, this is 10,000. What happens is it's not going to change or replace any of the zeros. I'm just pushing. So pushing is going to insert at the end of the current vector. So the end of the current vector is where this last 0 is. So this 10,000 is going to be inserted at the end of that. So after that, okay. So A6 is now a 4-element array. It's not a 3-element array anymore. Now, so that's how one way you can fill it up. Now, you could change, you could make A6 of 1 to be, say, some value, and then that will get updated. So you don't have to like just fill it up and leave it like that. So you could make it something like that. You could update, because that's what typically we'll do later. We will fill it up some initial values and then we'll update those entries. All right. So that's A6, the first index got updated. Now, this is what we typically do. We set up an empty vector. So I'm showing different ways we can create a vector. So the first is using collect method. The second is using the format of comprehensions method like this. Okay, that's more commonly used as well. The third is to fill with initial value of some length and just play with those values if you want, or with that size you want, or you can even add on top of it some more elements. So that's also possible. And another way is to create an empty array. If you especially don't know the number of elements you want to store right away, so it's a dynamic array right away. So you could create an empty vector like this, A7 equals like empty square brackets. That means it doesn't have any element in it. It's an empty vector. And then you can start pushing values to it. So we can say push A7, comma 1. So 1 gets added first, and then 90, and then negative 89. So A7 is going to look like 190 followed by 89, negative 89. So when you print it, when you print A7, you could notice that it's printing here as any in this case, because when you kind of set it up here through this approach of setting A7 equals empty vector, empty square bracket, Julia could not figure out the data type of this vector or the values that you're going to store in this vector. Okay, so it assigns by default any as the data type of the elements stored in this vector. Now, if in this earlier cases, you were specifying 1 to 20, which are integers, and then this is also an integer, and this is also here the fill thing that is 0, so that's an integer. So it was able to figure out the data types of those values. So it doesn't designate as any as the data type. But in this case, we created an empty vector, so it could not figure out the data type. So it started calling it as an array of type any, means it can store any value. Okay. So this is where if you create an array of type any, that's where you could really add elements of any yeah. So if you create an array of type like this is where if you set up an array like this, an empty vector, this type of an array, which is a type of which is array of type any, to this array you could add array elements of any data type. So which means I could add the next element to be Boolean if I want to. Let's try it out. Then I'm popping it. So let's go over this and then we'll. I'm doing that in the second array A8 here. So let's wait until that. So let's do what I have here with for A7. All right. So for A7, I create an empty array. Since I didn't specify any fill value or a range or anything, Julia is treating it as an array of type any. So even though you're adding integers later after that, it's still considered an array of type any. And when you print A7, it's going to print along with that values, that keyword any. So now I want to pop from this A7. So this negative 89 is going to be popped out. So I'm storing that as a pop value. So this is the case where I'm explicitly capturing the pop value. And I could print the pop value as negative 89 and print it out. And, and then I could print the contents of A7 after the pop operation. So after the pop operation, the negative 89 is not there. It's just having 190. Now I could push 100 to it. So it becomes 190 and 100. Okay. So just showing that you could push and pop to a vector, even though it could be of type any. Now, can we update an array? Yes. Later, we'll look at loops. So in other languages, say Java or any language, you could have used a loop to go through the elements of the array and update them. We could do that, but we have not seen loops yet. But I'll introduce one way that looks like a statement, but it's like a element-wise operation statement. So you could manipulate or change only for changing. Yeah, you can even access all the elements. You could access all the elements of an array using this dot operator. So let me say what it means here. So the current A7 has this 190 and 100, right? So I want to multiply each element in this vector by 3. So that I want it to become like 3, 270, and 300. Okay, so I want it to be, I want each element in this vector to be multiplied by 3, which we could easily do by writing a loop. But Julia also allows a more smarter way or a more efficient way of doing it in terms of the number of lines of code you will be writing. So by you could specify this dot operator before the actual operation we want to do. So we want to multiply each element by 3. So I put the dot in front of the multiplication sign. And so once you put the dot, it means you're going to access each element of that array. Okay. So each element of A7 is going to be multiplied. That's what it means. The dot operation means each element associated with the array preceding that, in this case A7, is going to be multiplied by this value 3. Now, just doing this won't change the contents of A7. We have to assign that back to that A7. So we are putting that equal to A7 equal to this, the result of this. But again, we want to change each element of A7. So we're putting the dot in front of that equal to. So this statement A7 dot equal to is going to be like each element of A7 is going to be changed by what you're doing on the right-hand side. So what we are doing on the right-hand side is each element of A7 is going to be multiplied by 3. Okay, so that's element-wise multiplication. So that, and after you do that, you can print the contents of A7. It's going to look like this: 3, 270, and 300. Now you could do some other operation as well. So this is the current content of A7. So now we want to subtract each element by 5. So what we could do is, again, A7 dot equal to A7 dot. Now this is a subtraction operation. So treat it as like I want to subtract each element by 5. So we'll do like A7 of whatever I minus 5, instead of writing like A7 of I, where I is the loop index, would have gone through minus 5. Instead of doing that, you're replacing this by a dot minus. Okay, so A7 dot minus 5. And so you would have assigned it like this: A7 of I equals A7 of I minus 5. So on the left-hand side, that index of I equals is replaced by dot equals. And on the right-hand side, that of I minus is replaced by this dot minus. So this is a very powerful, what do you call, feature that Julia has, that so that the code can be very small, short, and it will do a lot. Okay, and when it comes to data frames and stuff like that later, we could use something like this to change all the rows in the data, yeah. So to change, if you want to change the values of elements in a particular column across all the rows, we could do that. Okay, so in this case, it's a one-dimension array. So there even is one column, that's a one-dimension array. So if you want to change all the values in a particular column, you could go through this approach. Okay, so right now we're just looking at one-dimension array, so that's kind of very straightforward to visualize. And this again, I think will help. When I see, this is how we'll do typically in a for loop, and you want to change each element or subtract each element by 5. Run a loop with index I and do A7 of I equals A7 of I minus 5, and that's what we're doing here. All right, so that's kind of how you do it, element-wise manipulation of a vector. All right, now. Yes. Okay, so now what I want to show is, so we so far looked at just a vector, an array of elements. Now, what we could also have is a vector of vectors. And that vector of vectors could be of mixed type too, in the sense that let's create again an empty vector. Now, as of now, it could be, this is how we initialized A7 as well as an empty vector, right? And to this, we just added one element at a time, like 190, -89, and pushed and popped and so on. But to this A8 vector, I'm going to push one vector at a time. Instead of one element at a time, I'm going to push one vector at a time. So to this A8, I could push 1, 2, 3. That's a vector on its own. And that's why it's called a vector of vectors. So A8 of 1, okay, at index 1 for A8, this vector is there. This 1, 2, 3 is there. So if I call another push on A8 and pass this vector, which is a two-element vector, 1.5, 2.5. So this is a vector of float, whereas this is a vector of integers. So it's going to, now A8 of 2 is going to be a float vector. Then A8 of 3 is going to be a string vector, which is having a vector of strings. And then A8 of 4 is a vector of Boolean values. So Boolean values are represented as true or false, or the keywords. And then A8 of 5 is an integer vector. Then so far, again, this, at least this vector is of the same data type. Okay. Now, since we used any vector-based initialization for A8, it will also allow this. So even an individual vector, which is like what, A8 of 3, 1, 2, 3, 4, 5, 6. So A8 of 6 could be a vector by itself of mixed type. So one element of it could be an integer, another element of it could be a float, another element could be a string, another element could be a Boolean. So even though we may not need to go to this level of mixed type vector, but I just want to show that Julia does allow could be mixed type. And the reason is, for example, you could have a data set where the columns could be of different data types. So one column could be a string, one column could be an integer, another could be a float, and so on. So we could make use of this feature of vectors to allow mixed data type and read each row as a vector of this mixed data type. So that's perfectly possible. And that's why Julia allows that feature. So if you now print this A8, this is how it gets getting printed. So again, since you set it up as an empty vector like this, the any tag gets along with it because it could not figure out by the time of its initialization what could be the values stored in this. So it's like 1, 2, 3, 1.5, that all the string, the integer vector, the float vector, the string vector, the Boolean vector, and then this mixed type vector as well. So now if you want to again go through this dot operation with a particular vector, so let's say A8 of 5, which is this vector, and I want to increment each value, each integer in it by 2, I could say A8 of 5, that would be like this vector. And for each element in it, so I want to use a dot equal to, I want to increase the value by 2. So it's A8 of 5 dot plus 2. And that would make this increment each of these values by 2. Okay. So again, it's a long video, but I just want to cover all the features of vector in one video so that you can just open this video and just look at whatever details you want for any particular thing question. Now, one thing I would encourage you to try is, so we did see that Julia does allow mixed data type for provided, at least in this code, we see that provided we set up that vector as to this empty vector declaration. The other declaration, other ways we create these vectors are where you were able to pass values that indicated the data type. So they collect 1 to 20, all this are integers. So Julia doesn't assign this anything to A1, A2, and all. So you don't see that any tag that is not getting printed when you print A1 or A2. because it should be able to figure out from this, it has all integers, at least the range of this collect function. Similarly, here it's all again integers, and A5 again I think is all strings. So there's no ambiguity from A1 to A5 or even A6. When you say fill 0, that's again an integer. So now you could make it 0.0 to make it as a float. So now what I want you to try is, as a practice, and try and see. Let's say this is for practice. Let's say create an array A9 or vector A9 like this. Collect 1 to 20 like we did before for A1, and you could print it. And now to this A9, let's try to push a string and see what happens. Okay, let's see if this A9, which we think Julia would have started to consider as an integer array because the range of the values is 1 to 20, that those were integers. Can we add a string to this array? Let's check it out and see. I thought I was asking you to do it, but since I typed out the code, let me just take it myself. No, so that's the thing. Okay, so very important thing to note. So A9 initially is declared like this, collect 1 to 20. So it's printing that A contents of A9 because we're printing it here. So now to this A9, I am passing a string. It's raising an error that you cannot convert an object of type string to an object of type int64. So the int is by default int64. 64 bits are allocated to store the integer. So that means with this approach of specifying some way what could be the initial, what could be the data type of the array through the values like this, collect, range, or the fill method. You could, so let's try with fill. So fill 0, let's say the length is some 10. So it will be a 10 element array of value 0 to begin with, the A9. But then you're trying to add a string to it. It won't take it, okay, because A9 is now an integer array. Now, can we make it a float? Yes. But again, you cannot push a string to a float array. So again, that problem will come up. Okay. Now let's try this. This is, let's make it back as an integer array and let's try to add a float. Is it allowing a float? So this is how you kind of try to figure out and enhance your understanding of the language. Yes, so it is allowing the float. So, oh, I didn't print it out. Let's print it out and see how it's getting stored. Push. So let's say this is before the push. And this is after the push. Okay. So the float, let's pass some 2.3. Let's see what happens. Okay. All right. So when it is 0, that's not a problem because 0 is considered default filler. and we already fill with zeros. But when you want to store anything other than 0, it raises a problem. It's 2.3, and that's a float. And I have declared A9 as kind of like an integer array. So if you want to be able to push 2.3, you should say 0.0, and that would push 2.3 without any problem. So the initial A9 is now all 0.0s. So it is considered now as an array of type float 64. And when you push 2.3 to it, there's no problem. It gets added quite easily. So this way, Julia will enforce arrays of a specific data type. Okay. So if you want an array of mixed data type, then you have to make it like this. A10 initialize an empty square bracket. That makes it an array of type any, because there's no way Julia could figure out what could be the data type of the elements stored in this array A10. So to such an array, you could push anything you want. So A10, I could pass 1, then push A10 2.3, then push to A10 a string, and then you can push a Boolean. And then you can just print out and see whether how A10 looks like. Okay, so let's try it out and see. Okay, so this is the any tag gets added to this A10, and you have 1, 2.3, make 2, so it makes the data type. So A10 is an array of vector of mixed data type, because we set it up using the empty square bracket approach that would allow the array to be of mixed to store mixed data type. But if you created the array using the other approaches, like the collect method or the fill method or even the comprehension method, then the vector becomes a vector of a specific data type. Okay, I hope this video is helpful. Just go through it slowly, little at a time, and try to understand each phase of this video, and just practice like what I did at the end of the video on your own to get to reinforce your understanding of this material. Okay, let's stop the video with this.